Dennis Ledbetter, Tri-Technic. We're a construction company. We're a contractor that works in infrastructure, primarily power grid infrastructure, transmission line, power plants, substations, and now we're moving into these battery energy storage projects. Yeah, this project is a battery energy storage project that utilizes lithium-ion battery chemistry technology. It's primarily designed to be a high-power, relatively low-energy project. The project is designed for 30 megawatts of power, 20 megawatt hours, which means that it will maintain 30 megawatts for 40 minutes. That's the design criteria for it. Primary use for this is for spinning reserve, for ancillary services on the grid, which would be frequency regulation, voltage support, that sort of thing, due to the high concentration of renewable energies, primarily solar, here in the Imperial Valley. These are lithium-ion. They're Samsung batteries. We're mostly builders. We're not in the battery technology. For us, we see the various batteries as a DC source, and so we know that lithium-ion has pretty much is the predominant technology out there in the marketplace, because they're able to produce and scale for deliveries. Many of the other technologies, there's a lot of new technologies, but they're unproven and they cannot scale to provide delivery on like this particular project required 5,760 batteries. So there are a relatively few number of companies in the world that can supply just from a delivery standpoint, especially within a tight time frame as this project is. Well, the plant itself, which is determined by the individual batteries, is a 25-year life. Now, all batteries, all sources of energy degrade in time, things like lights and everything else degrade over time. In order to maintain the design capability, this project has future expansion built into it, so that we will be adding additional megawatts as over the years. So approximately every 5 years, we have to add one more megawatt to maintain the performance of the plant. So they have a very, very long and a very successful and productive life to them, really. If you compare this, a 25-year life with a gas turbine or anything else, a rotating machine, these perform very well with very minimal maintenance. This facility, including the interconnection station, is approximately 5 acres. We're not utilizing the entire site. Of that 5-acre area, we're using probably 2 acres, 2.5 acres maybe at the most. So the B.E.S.S itself actually sits on less than half an acre of ground. So it's a very high concentration of power on a very small footprint. The control room is basically the nerve system for this whole project. All of the physical, mechanical equipment that we have converters, we have transformers, we have batteries, chargers, a lot of other power supplies. We have all the support auxiliary systems, like we've mentioned before, the HVAC systems, the fire suppression systems. All of those tie into the equipment that's in the control room. And all of those, all that data is transmitted to IID via their SCADA system, which is their supervisory control and data acquisition. That's what SCADA stands for. And they collect all of the data, but they can also control the project remote from their power plant control. So they have a remote. They have remote terminals there in the power plant control room, as well as having terminals here locally. So any operator can step into this. They can operate. They can see all of the monitoring points here, temperatures and voltage outputs and all of that sort of thing. They can see all of it for every single item on the screens, the multiple screens here in the control room, but they are also, all the same data is transmitted to the power plant control room, where they have all the same visibility there. The control room here is physical in that it monitors all of these points, which there's thousands of data points that are being monitored continuously in every one of the systems. All of those are brought into the control room equipment, and they're logged there, they're processed there, they're transmitted. There are certain functions that are done with that, comparators and that sort of thing, so that we have, if this occurs, then this result and that, and so they're looking for that and they're comparing that all the time. So it's a very sophisticated control system. GE basically owns this system, and this has been the kind of the division of responsibilities. GE provided all of the primary proprietary equipment, the inverters, the transformers, the batteries, the plant control systems, and all of that sort of thing, and the software that controls them all. Those are all proprietary systems. Tri-Technic basically built all the physical facilities and installed all of their proprietary. So we installed it all and we connected it all, but making it talk to each other and turning it into a system that is usable to the owner, that was all GE's responsibility, and they did a pretty spectacular job at it. Their system right now also integrates with the interconnection, which is the substation, the 92 kV substation that's right adjacent to us here. All of the protection and metering and relaying controls, all of that sort of thing resides in our control room for the substation as well. So the control for the B.E.S.S, the battery energy storage system facility, and the substation, the interconnection substation, all reside in the control room. So there's quite a lot there, actually. And most of our connections here, about half of them are connected with copper control wiring, and half of them are connected with fiber optics. Most of the connections between the facility here and the control room are connected via fiber optic. So all of the technologies that are used and all of the systems that are being employed are all very cutting edge. So, and in order to get much deeper than that, you'd have to talk to GE, because that's all they let us know.
My name is Max Marquez. It started off with OTI and OTR engineers getting together. We branched out in from Durathon. We had Durathon. That's what we're using for energy storage, which is more of a power battery, or more of an energy battery instead of a power battery. These are more of a power battery, fast response. They talk with all the grid operators, see what they would like to see what a battery energy storage could do for them, and they came up with the OTR guys did all the specs for this project. And it's the largest one we have to date, and it's here in Southern California. And we got it in on good time, good manner, and it came together really great. Because of the batteries and they wanted to get away from halon and totally evacuating oxygen from a space this big. It's quite dangerous for any kind of like rescue or anything like that. So we came up with the new state-of-the-art, very costly fire suppression.
What we have here is first of all, there's the fire detection system. We have a standard fire detection system with smoke detectors, and we are not going with heat detectors because they're too slow. But smoke detectors, very sensitive, a lot of smoke detectors throughout the building in all the strategic locations. In addition to that, on the detection side, we have a B.E.S.S system, which is a very, very sensitive, very controllable fire detection system. It's an active system that pulls air through sensors on a continuous basis, runs 24/7, 365, forever. And so if a person were to strike a match in one of the corners of this building, that B.E.S.S system would detect it in a matter of seconds, and it has a number of levels of alarm, so that because it's so sensitive, we want notification early, but we don't want a release of the expensive fire suppression system. So what it does is it gives us the very earliest detection of potential fire, so that operators can come and check. We have closed circuit TV cameras throughout the building, on the outside of the building, so that the first order for the operators here, if they get an alarm, is to scan the facility through the cameras. They would dispatch an operator to the facility to put human eyes on it, and then with the hope that with these batteries, we do not believe that they're an explosive technology. The fire should be, if left undetected, can spread and become a very serious matter. But it's a very slow process to initiate, and so we believe we have time to come and to inspect any alarms. The system has both alarm initiation pull stations that if an operator sees anything, they can pull it and set the alarm. There's also abort stations strategically located throughout the facility, so that if there is an alarm and it starts counting down to an initiation, they can abort that. This can be overridden by a person, so that it's very automatic, but it also has provisions to be overridden by human beings. The HVAC system here is not primarily a building cooling system, or for human comfort. It's not a comfort system. It is a process cooling system. So it's sized and installed to cool batteries and keep them at their optimal temperature for operation. Their optimal temperature is a minimum temperature of 68 degrees Fahrenheit, a maximum temperature of 77 degrees Fahrenheit. So we have to maintain the batteries throughout both their charging cycles, their discharge cycles, and their their steady state cycles within those temperature parameters in order to maintain the manufacturer's warranties and assure the length of life for the project. We employed Train company. We used their products here. These are packaged units. These were the most economical given the requirements that we had and the time frame that we had. They were chosen that way. To cool the batteries, there are 10 package units that are the largest package units that you can get for this purpose. Going beyond this then requires chillers and cooling towers and quite an elaborate system. This was a good balance. The project itself requires the battery room here, the enclosure here requires 280 tons of cooling in order to maintain that required temperature. We designed and constructed the building to add a very high level of insulation here due to the high ambient here in the Imperial Valley. It gets very, very hot here, as you well know. So the design temperature criteria here was 125 degrees Fahrenheit. So our system has to perform, and the project has to provide services to IID, everything up to 125 degree ambient temperature. So that was the design criteria. For our client T Global, they have another battery energy storage project in the city of Santa Paula, California, and that one will be quite a bit different than this project in that one will be containerized batteries and inverters and that sort of thing. It won't be an integrated building. That one, the first phase of it is 5 megawatts, but 20 megawatt hours, which is the same size as this facility. The ultimate build out on that project, which is the second phase, goes to 15 megawatts and 60 megawatt hours. So that would be basically 3 times the size of this facility here. So that project is in engineering right now and procurement. It's going to be a very, very fast-track project in that we have to have the first phase online by December 31st. So transformers and inverters and batteries and everything are being procured right now. All of the construction engineering is just beginning. All of the interconnections and that sort of thing are just getting started.